Hello good people, I would like to talk about a nucleophilic substitution reaction. In particular, I would like to look at the SN2 mechanism. What does SN2 stand for? The S stands for substitution, the N stands for nucleophilic, and the number 2 tells us that the rate determining step, so the slowest step of the reaction mechanism, involves 2 molecules. It is a bimolecular step. Generally speaking, a nucleophilic substitution reaction involves a leaving group on the substrate, so it's the leaving group here, and a new nucleophile. I would also like to note that the leaving group itself is a nucleophile as well. So the new nucleophile comes in, it displaces, substitutes the leaving group, and the leaving group, as the name suggests, leaves. So what happens? Let's look at an example. So I have drawn 1-bromopropane here. Please note that 1-bromopropane is a primary haloalkane. So the carbon that is bonded to the halogen is bonded only to one other carbon. Therefore, this here is a primary carbon, and this whole thing is a primary haloalkane. Let me get rid of this for a moment. Another thing to note is that the electrons of this bond between the carbon and the bromide are not shared equally. So the bromine will pull the electrons towards itself, and as a result it will have a partially negative charge. Consequently, the carbon will have a partially positive charge. So that if a nucleophile comes in, our friend hydroxide here, it will be attracted to the partially positive charge of the carbon. And the bonds of the carbon-bromine bond will, the electrons of the carbon-bromine bond will end up on the bromine. So what happens? Well, for a brief moment in time, we have this transition state here. So the species in the bracket is known as a transition state. At that particular moment, the hydroxide, you could argue, is half in, and the bromide is halfway out. Once that is sorted, we will end up with the final product, which in this case is 1-propanol. So the hydroxide is now fully bonded to the primary carbon, and the bromide has left. Please note that the creation of this transition state, so the slow step, is the rate determining step. And as you can see, it involves 2 molecules. That is why this is an SN2 mechanism. Finally, I would like you to realize that a primary carbon is far more susceptible to nucleophilic substitution, to the SN2 mechanism of a nucleophilic substitution than a secondary carbon, which is more likely to undergo an SN2 substitution than a tertiary carbon. That is all for now, and I will see you on the flip side.